This video covers how to interpret the results of the MELD Graph pipeline. You will find the guidelines on our GitHub at MELD project MELD Graph, and you will find the full documentation by clicking here. So we can go directly to the interpretation of the MELD Graph pipeline results. The MELD Graph pipeline output a PDF report which summarize the results of the pipeline and also the prediction as a Nifty file. And in this tutorial, we're going to show you how to interpret the PDF report and how to quality check your prediction as a Nifty file.
To want to do once you've run the MELD Graph MELD Graph algorithm is to interpret your results. So in your MELD Graph data folder, there's a folder called output, and in the output folder, there's a file called prediction reports. In here, for each of your subjects, there will be a folder, and if you open that folder, there will be some folders called predictions and reports. And in reports, there's a PDF file called MELD report and your subject ID. And I'm going to show you an example of one now, and we're going to interpret it together. MELD report, the first thing you can see is that it's for patient subject 00003. And the next thing that you can see is it tells you some information um, about what algorithm has been run. So this patient has been run through the MELD Graph surface-based FCD detection algorithm. On page 1, you'll see an overview of all the detected clusters, and then each subsequent page will be detailed information about one cluster. And just the disclaimer that this is MELD Graph surface-based FCD detection algorithm is intended for research purposes only and has not been reviewed or approved by the Medicines and Healthcare Products Regulatory Agency, MHRA, European Medicine Agency, or any other agency, and any clinical application of the software is at the sole risk of the party engaged in such application. There is no warranty of any kind that the software will produce useful results in any way. Use of the software is at the recipient's own risk. So there's the disclaimer. So then what you see is where the clusters have been identified. So in this patient, one cluster has been identified in the right hemisphere, and this is where it is. If we go to the second page, you'll see the cluster on the T1 in red, and in orange, you can see the most salient vertices. So those were the vertices, the voxels, that were used to drive the classifier's decision. And below, you see the T1 without the cluster, so you can see the same area and see whether it seems to have any abnormalities. Next, you have some information about the cluster. So this is a cluster on the right hemisphere. It's around 8 centimeters. It's in the supramarginal region, and the classifier is around 80% confident that this is an FCD, so it's fairly confident. It also tells you the voxel value on the Nifty, which is 1 in 100. So if you were to go back to the Nifty prediction, any voxels that were labeled 1 or 100 would be part of this predicted cluster. And then you can see each of the features, and you can then see how abnormal they were, which is the Z-score, and how salient, the colour is how important was that to the classifier. So for this example cluster, one of the main features that's been used to drive the classifier's prediction is the cortical thickness. This has a Z-score of around 4 for the normalized cortical thickness. And you can see that it's a kind of dark pinky colour, so that was important to the classifier. It's also characterised by blurring of the grey-white matter boundary with a Z-score of around minus 1.8 and some flare hypointensity in the grey matter with a Z-score of about minus 1.5. So those were the main features used to drive the classifier's prediction. And this is important because you can now go back to the cluster, you can open it on your T1 and view it with your flare data and see whether the identified area has any of the features that we described. Does it have increased cortical thickness, blurring of the grey-white matter boundary, and on the flare, do you see hypointensity?
It is important to quality check the results of the pipeline to check and ensure that the predictions are not due to obvious free surfer reconstruction errors or scan artifacts. For that, you can use the scripts that we created and that will automatically you load your results on FreeView, which is a viewer of FreeSurfer. We are now going to do this together. Here I have my MELD Graph folder, which contains the MELD Graph pipeline scripts and my MELD data folder. So I'm going to go in the MELD Graph folder and open a terminal there. If you have the Docker version of the MELD Graph pipeline, you can follow these instructions here. It is important to note that Docker does not allow GUI interface. Therefore, you will need to have a standalone installation of FreeSurfer or FreeView to be able to use QC scripts. However, if you have a native installation, you can follow the guidelines that are provided here. So for the Docker installation, we are going to first export our FreeSurfer home. So once you have installed FreeSurfer as a standalone, you can export it. So I'm going to replace this path by my FreeSurfer installation. And then I can source it to activate the environment. So you can see now that FreeSurfer is activated. Data folder, which is this one. And we can enter. And you can see that it is opening FreeView and it is loading your T1 scan, your flare scan, the prediction on the left and the right hemisphere, and also the left and right surfaces. So what you can do from here is, for example, remove the flare so that you can see the T1. You can also, by clicking right and moving your mouse, you can change the size and make it bigger or smaller. You can also move on the brain by clicking left on your mouse and moving. And what we want to do is we want to find the cluster. So I'm going to look for my cluster. And I can see it here in blue. You can remove the surfaces if it's easier to see. So I see it there. And I'm going to put the surface back to check that the surfaces might not have been a problem here. So you can quality check that the surfaces seems okay. And you can also put flare back to check. So you can go back on the documentation and you will have more information about how to QC and what to check for the surfaces and the cluster.